Today's lesson is on present value of an annuity and amortization. So let's suppose we have an ordinary annuity where we deposit $300 at the end of each year for 10 years with an annual interest rate at 7%. The present value of this annuity is equal to the amount that we would need to have deposited in one lump sum today at the same compound interest rate in order to produce the same balance at the end of the 10 years. So that's what present value means. So we can set up a compounding interest formula from before our previous lessons. A equals P 1 plus I to the n equal to the annuities formula that we used in the future value of an annuity. S equals R parentheses 1 plus I to the n minus 1 all over I. So if I set those two things equal to each other, if I set the A, which is the future value, to the equal to the S, which is also the future value, I get P times 1 plus I to the n equals R times the quantity 1 plus I to the n minus 1 all over I. Now, what I would like to do is I would like to solve for P. So I want this P to be all by itself. So I need to get rid of that 1 plus I to the n. So I can basically divide it from both sides, or we can do something called multiply by the reciprocal. The reciprocal of 1 plus I to the n is 1 over 1 plus I to the n. Another way of writing that is just 1 plus I to the negative n. Because it was in the denominator and we moved it to the numerator, that changes its exponent from a positive to a negative. So if I simply multiply 1 plus I to the negative n on both sides, what happens is the 1 plus I to the negative n times 1 plus I to the n divides out nicely, because when you have 1 plus I to the n times 1 plus I to the negative n, because these two have parentheses have the same base, you can basically add the numerators, and that gets 1 plus I to the n minus n, which is really 1 plus I to the 0, and anything to the 0 is 1. So it basically undoes itself. Okay, so the 1 plus I to the negative n and the 1 plus I to the n divide out nicely, and you're just left with P. And that's what we were hoping to have happen. So we have P equals R, and I'm going to go ahead and put the 1 plus I to the negative n right here. Then we have the big parentheses with all of the other stuff in there as well. Okay, so that was step 1. I multiplied both sides. And now we're at step 2, says to distribute the 1 plus I to the n, negative n through to the numerator. So we have P equals R, and I'm distributing here. So in the numerator I have 1 plus I to the negative n times 1 plus I to the positive n minus, and then I take 1 plus I to the negative n times the 1. That gets 1 plus I to the negative n again all over I. And what did we notice that happens right here? We just talked about this a little while ago. If you take 1 plus I to the positive n times 1 plus I to the negative n, it turns out you just get 1. So we have the formula P equals R, parentheses. The highlighted blue just turns out to be 1 minus 1 plus I to the negative n all over I. And we like to have the brackets around those numerators, so that reminds us that all of those are grouped together because of the grouping symbol divide sign. And that is our new formula for P, which is present value of an ordinary annuity. So if you notice, this is our new formula, and you came up with that, so that's kind of cool. P, again, still stands for present value of an annuity. R is the recurring payments, the same as before. M is the number of payments per year. T is the number of years. Lowercase r is annual interest rate in decimal form. N is the total number of compounding periods. Again, we have our formula N equals MT, which is the same as before. And I is the interest rate per period, where I is equal to R divided by M, the same as before. So we're going to go ahead and use this formula for present value of an ordinary annuity to solve our first example. So our first example, Simone student and Greta graduate are both Lone Star College graduates. Both agree to contribute to the LSC Alumni Fund. Simone says that she will give $500 at the end of each year for 5 years. Now Greta, on the other hand, prefers to give a lump sum today. What lump sum should Greta give to equal the present value of Simone's annual contributions if the endowment and fund earns 7.5% interest compounded annually? All right, so let's go through our values that we're going to need to find. So we are trying to decide how much lump sum Greta should give, okay, so that it will equal Simone's contribution. So Simone gives $500 at the end of each year. So that's $500 as a R, capital R, a recurring payment. She does this for 5 years. And the lowercase r is the interest rate, so that's 0.075. It says it's compounded annually, so m is equal to 1. To find n, I'm going to multiply m times t, which is 1 times 5, or 5. And the I is going to be 0.075 divided by m, which is just 1. So that reduces to 0.075. So we want to know what the present value lump sum Greta should give. So that's going to be P. So what should she give? So at the end of the 5 years, the two contributions would be the same to the annual fund. And that's what we're going to find here. So I'm going to use the formula. P is equal to R, which is 500, times parentheses. In the numerator, I have 1 minus 1 plus I, which was the 0.075, to the negative n, which was 5. Close that bracket. All over the I, which is 0.075, and then we can close that entire parentheses as well. So I'm going to need to get a calculator out. So I have 500, then the parentheses, then another parentheses, because every time I see a bracket or parentheses, I got to type it. 1 minus, open up another parentheses, 1 plus 0.075, parentheses, caret raised to the negative 5. Now that's up in the exponent, so I need to get out of the exponent, close that parentheses, but I'm not going to do the big parentheses until after I finish dividing by the bottom, right? So I'm just closing that bracket. Then I divide by 0.075, then I close the big parentheses. When I hit enter, this gives me $2,022.94. Okay, so that's how much Greta will give today. Now let's just kind of think about, what did Simone give? Simone gave $500 at the end of every year for 5 years. So Simone ended up giving 500 times 5, which is $2,500. And that's what she gave periodically over 5 years. Okay? Now Greta only gave one lump sum. She gave the $2,000, but she knows that it's going to earn 7.5% compounded annually. So she only gave $2,022, but that equaled Simone's $2,500 contribution because of the interest that Greta was accruing over the 5 years. So that's one application of present value of an ordinary annuity.